Good morning. For me, it's showing computer science. Do you want to reload the page and see if it changed? Good morning. Good morning, everyone. Wait a little bit longer to get started. I need to send a remind message out anyways. Good morning. Good morning. Good morning. Gonna wait for a few more viewers. Gonna wait about 30 more seconds. Oh, cool, I'm at 25. All right. So I'm gonna go ahead and start. First of all, I wanted to say I sent out a remind message this morning, and it says that I'm working on putting grades in, the first batch of grades, so that would be assignments 1, 2, and 3. So those should be put in the grade book by the end of the week, so you'll have some indication of what your grade is. That being said, if you did the assignments as if your program does what it's supposed to do, then I'm going to give you full points. So I'm assuming that most of you probably have 100%. Another thing I wanted to say, I got a few emails about Codeboard not working for some people, so I wanted to show you what I think the problem is for most of you. If I go to Codeboard, so one of the things about Codeboard is that the main method has to be in a class called capital M main. Okay, so if you turn in a program that is not, if you delete the main.java file and you rename it with your own class, then it's not going to work on Codeboard. Okay, so keep that in mind. All right, and if you're still having problems submitting via Codeboard, we can talk during class today. Okay, so what are we going to talk about today in class? Well, with my SL students, we are going to talk about what's called static fields and methods. And in my HL class, we're going to talk about an application of stacks. Okay? So, let's get started. Switch this over. All right. So once again, HL students, stay on the live stream, and I will call you to pay attention in just a moment. Well, maybe not just a moment, but like 10 or 15 minutes. Okay, so I have altered the main method. So we're still working with this myVector class, and I've changed the main method so that I start out with, I created 5 vectors, okay, and then I did some changing of the values of the components of that vector. Okay, so let's look at the myVector class. So there's a thing called a static variable, a static field, okay? And so I have 2 of them right here. And a static field is a field of the class as a whole. Okay? So there's not, if we think about X and Y, for example, right here, each object in the class has its own X value and its own Y value. Okay? But a static variable, a static field, individual objects do not have the static field. It's a field of the class as a whole, okay? And so you define a static field just by putting in the keyword static after public or private, okay? So I've created 2 static fields. The first one is called novex, which stands for number of vector objects. Okay, so how many vector objects have I created in my program? That's what that variable is supposed to have. And also no method calls, which is the number of method calls in total that the program uses. Okay, so I don't know, I mean, a lot of times static fields are used to count the total number of times something happens in a program. An example that popped into my head was maybe you want to figure out how often something is used. Like how often does a user close a window? So maybe you have a static field that is number of window closes, where each time the window gets closed, that number gets increased by 1. Okay. One of the things about static fields is that they must be initialized in the class definition. Okay, so that's a little bit different. If we think about these regular fields, I wouldn't say private double x equals 0, private double y equals 0. That doesn't make any sense because what x and y are equal to depends on the particular object. But for static fields, I need to, because they're for the class as a whole, I need to say what their starting values are. So I'm saying that the number of vectors starts at 0 and the number of method calls starts at 0. Okay? So then what I did is I went through all of my methods and I modified them. Okay, so for example, we know that every time we create a new vector, the constructor of the vector is going to get called. So for both of my constructors, I added a statement that increments the number of vectors. Okay, so anytime that a new vector object is created, that number is going to increase. Okay, so this will go from 1 to a different number. All right, and then also for all of my methods, I added an increment to the number of method calls. Okay, you got to be a little bit careful here because you can see in the constructor I incremented the number of methods last, but I wouldn't want to do that in these methods because if I did something like this, if I put number of method calls plus plus after the return, then it's not going to get incremented because the method has already returned. So basically everything after this line is not going to happen. So I need to put that before. So every time a method gets called, I increase the number of method calls by 1. Okay. Cool. And then I added a couple of accessor methods so that I could get the number of vectors and I could get the number of method calls. Okay, so that's how I modified the myVector class. All right, so let's go back to the main method. Going back to the main method, you can see that I have created 5 vectors. 1, 2, 3, 4, 5. They all have the same components, but that's not really important. Okay, so if I try to access the number of vectors, okay, it should give me 5 as the answer. Okay, and then you can see that I changed the x component of A, I changed the y component of C, I changed the x component of B. So I've called 3 methods of the myVector class. So the number of method calls should be equal to 3. Okay. So then what I have is I just print the number of vector calls and the number of method calls. Now, how do we? Oh, by the way, I forgot to mention that these methods here that get the number of vectors and get the number of method calls, they are what are called static methods. And static methods are methods of the class as a whole. Okay? So these are not methods of a particular object within the class. They're a method of the class as a whole. Okay? So if you want to call a static method, so again, a static method, you define it the same way as you do a static field. You just put static after the access modifier. So public static int, public static int. You call a static method by using the name of the class itself, dot name of the static method. So it doesn't make sense to say something like a dot get number of vectors. That doesn't make sense because get no vex does not belong to A. It belongs to the myVector class as a whole. Okay, so if I want to call a myVector static method, I do myVector dot get the number of vectors. Okay, myVector dot get the number of method calls. All right, So I'm going to compile this. Let's hope it compiles. Compilation successful. And I'm going to run it. And we can see that the first line is printing to the terminal, get the number of vectors, okay? So we can see that the number of vectors is 5 because I created 5 new vectors, okay? Get the number of method calls. We can see I called 3 methods, and that's in the second line right here. So the program is working as we thought it should. Now, what would happen if I, for example, comment out one of these, and maybe I comment out 2 of these? So now I'm only creating 4 vectors, and I'm only calling 1 method. So this should change to 4.1 over here. Let's try it out and see if it works. See how it says 4.1 now. All right. So that is static fields and methods. I wanted to give just a really quick example of you've already used static methods before a lot, and that is in the math class of Java. Okay. The math class of Java has entirely static methods. Okay. All the methods in the math class are static. See how I'm in the documentation. So here's the tangent function is in the math class, and it's a static function. So if you want to get the tangent of some angle, you would say math dot tangent of your angle, like that. Okay? So you're not calling the tangent function of a specific math object. You are calling the static method of the entire math class. Okay. In fact, if you look at the math class, it doesn't even have constructors. All right. There's no constructor for the math class. So, for example, it's impossible to say because it has no constructor, it doesn't make sense to say something like I don't know, math x equals new math. That just sounds funny to say, right? New math. I'm creating a new math. That would give an error because the math class has no constructor. Okay. So you guys have been using, I'm assuming that last year you used the math class at some point, and so that is how you're actually calling a static method. Okay. So there you have it. That was my lesson for the SL students, and you are going to be working on an assignment where you create a class that has some static methods and fields, and yeah. So if you are in SL, you can tune out of the last part of this this live stream, and I'll call you over to the Zoom room in just a few minutes here. All right. So now I want to talk to the HL students. Let me see if there are any questions. Okay. So for my HL students, I'm going to go over to, I just want to show you one thing before I start. We've been talking about stacks, and you created your own version of the stack class, okay? However, there is a predefined stack class in Java, okay? So, so in some sense, the work that you did was just to show how the stack class works, show that you understand how the stack class works. But if you were actually writing your own program, you might consider not using your own stack class and using the stack class that has already been defined for you. That's one of the advantages of object-oriented programming, is that you can use other people's work. Okay. That being said, if you want to use the stack class, you have to include an import statement, java.util.stack. Okay. So we've got a constructor. The stack constructor takes no arguments and it just creates an empty stack. And it has 5 methods. It has isEmpty, peek, pop, push, and there's one that I didn't have you guys define in your own stack class, which was search. Okay? So there you have it. The other thing I wanted to talk about was a quick application of stacks. So one of the applications of stacks is to evaluate parentheses. Okay? So what if you have a, I'm going to turn off this light because it's giving me a shadow. What if you have some parentheses? Okay, so maybe you have something like this. All right, this is a valid parentheses statement. This makes sense as parentheses. Why? Because you've got these 2 parentheses go together. You've got these 2 parentheses go together. You've got these 2 parentheses go together. And you've got these 2 parentheses go together. So that makes sense. Okay? If you have something like this, that does not make sense because these 2 go together, but this one closes a parentheses, but it doesn't have anything that opens it. Okay. Similarly, if you had something that was like maybe, I don't know, like that. These are just all open parentheses, so none of them are closed. So you can actually use a stack to test whether a statement of parentheses such as this is actually valid. Okay, so here's how it might work. Okay, every time. So basically what you would do is you would take in a parentheses statement and you would parse it. So you would go character by character down the string, okay, because this would basically be a string. All right, and every time you encounter I need to focus and zoom in. Well, focus. I wish I could do manual focus because I feel like it focuses better for a second there and then it gets worse. Every time you encounter this character, push the stack. Okay. Every time you encounter this, you pop the stack. Okay. If you try to pop an empty stack, then that particular parentheses statement is not valid. Okay. Also, if you get to the end of the input, and stack is not empty, then it is also not valid. Okay? Come on, focus. Maybe I do need to turn the light on. Turn it back on. Focus. Okay, that's better. So let's see how that works with this statement right here. Okay? So I have this. Let's suppose that this is my input. Okay? So going to the first character, that is one of these. So I push the stack. So here's my stack. I'll put my stack over here. My stack has this on the bottom. Then I encounter this statement, or that character. So again, I push the stack. So now the stack has, and here's sort of the ground level of the stack. Okay. Now I encounter a closing parentheses. So now what I'm going to do is I'm going to pop off the stack. So this one is now off the stack. Okay. Then I encounter an open parentheses. So now I push the stack. Then I encounter an open parentheses. So I push the stack. Now I encounter a closed parentheses. So I pop it. That one goes away. Now I encounter a closed parentheses. So I pop it. Now I encounter a closed parentheses. So I pop it. And now I'm at the end of the statement. So I check, is there anything left in my stack? And there's not anything left. Everything is X'd out. So this is valid. This is a valid parentheses statement. Okay? What if I wanted to apply that to this statement of parentheses? It was like this. This one that we were talking about. What would you do here? Well, here's your stack. You encounter an opening parentheses, so you push the stack. You encounter an open parentheses, and you push the stack. You encounter an open parentheses, you push the stack. And then you got to the end of the statement. There are no more characters, so you check, is the stack empty? And no, it is not, so this is not valid. Okay, I'll do one more example. Maybe something like this. Okay. So here's my stack. Now this is obviously not valid because this one doesn't, this closes a parentheses, it never opened. Okay. So here I encounter an open parentheses. So I push the stack. Here I encounter a closed parentheses. So I pop the stack. I'm just Xing out, but if you were to actually pop the stack, you kind of remove it completely. And then here I encounter a closing parentheses. So I pop the stack, but the stack is empty. So I'm trying to pop a stack that doesn't have anything in it. And anytime you do that, you know you've have something that's not valid. Okay. So from what I've read, I've never done any compiler programming myself, but compilers use a stack to check your parentheses in your, when it's, checking to see if you have a valid program. It parses your entire program and has a stack, and it checks it to make sure that all the parentheses work out, all the curly braces work out, all the square brackets work out, and all that stuff. Okay? So your assignment for today is to basically implement a Boolean method that checks parentheses. So it takes in a string from the user, like this maybe, and then it spits out true or false depending on whether that is valid or not. Okay? So that's my lesson, and let's go ahead and migrate over to the Zoom room. Okay? Bye for now.